So here is a question on inductors that was a little bit difficult for students. So the question is, Tia needs to produce a solenoid that has an inductance of 2.71 microhenry. So the inductance is given, that's 2.71 microhenry, and she constructs the solenoid by uniformly winding 1.05 meter of thin wire around a tube. How long in centimeters should the tube be? So an inductor is made by winding a thin wire over a circular tube. So the length of the winding is given. It's a 1.05 meter. That's actually the wire, the length of the wire is given. And when that is wound over a tube whose radius is not given, but you have to finally find the length of the winding. The number of turns is not given. The radius of the tube is not given. All you're given is the length of the thin wire used. So that's why it was confusing. But let's break this down. This is what an inductor is. So you can see that the cable is wound over a circular frame. And the formula for inductance L is mu naught n squared A by the length. We are asked to find the length of the winding. So the caps L is the inductance and the little l is the length of the winding. Mu naught is the permeability of free space, which is 4 pi times 10 to the negative 7. N is the number of turns. It's the total number of turns in the solenoid. A is the area of cross-section. Because it's circular, the area of cross-section is pi r squared. Yes? And what about the length of the wire? How is it related to the number of turns? Well, we know that one winding is equal to the length of the circumference, which is 2 pi r. So if there are n windings, then 2 pi r times n should give you the length of the wire. Again, 2 pi r is the length of one circumference, and therefore 2 pi r times the total number of turns should give you the total length of the wire. So that is the idea. So x, I'm going to take the length of the wire as x, which is 1.05 meter, and 2 pi rn is x, and the area is pi r squared. And so we will substitute this into the formula for inductance. But before we do that, let's make n the subject here. So from here, n is going to be x by 2 pi r. Yeah, when you bring 2 pi r to the right side, it becomes n is x divided by 2 pi r. And then we can substitute the value of n as x by 2 pi r. But remember, it's squared. So the whole thing must be squared. And then we have the area. And the area can be substituted as what? Pi r squared divided by the length of the winding. Now, in the numerator, we can square each term. So that's x squared by 4 pi squared r squared. All right, times the pi r squared. So divided by the length of the winding. So in the numerator, we can see that the pi r squared cancels, but remember there is one pi here because it's pi squared. And then you have the mu naught x squared. So mu naught x squared divided by 4l, because dividing by 4 and then dividing by the length, it just means dividing by 4 times the length. And then you have the pi. Now, rearranging it, I'm going to take this length of the winding to the left side, goes to the numerator, and the inductance comes to the denominator. Simple, huh? So you get that mu naught x squared by 4L times pi. Now we know that mu naught is 4 pi times 10 to the negative 7. So that's mu naught. X is given as 1.05 meter. But there is a square on that. Divided by 4 times the inductance. The inductance is 2.71 microhenry. Now micro is 10 to the negative 6. So 2.71 times 10 to the negative 6 times pi. Alright, so now we can get rid of those pi's there, cancelled, and even the 4's can be cancelled. Let's do that, and then you just got to calculate that. You get 1.05 squared divided by 2.71, which gives you 0.0468 meter. If you want it in centimeters, it's going to be 4.68 centimeters, or rounded off to 4.7 centimeters. That's how you do this problem. So you can see that there were multiple substitutions that you had to make. It's just a case of thinking, but I agree that this could have been a little tough. So here's why I worked it out for you. So let's hope that you understood this, and we'll see you on the next video. Thank you.